Hello everyone, I'm Alessandro Innocenti. I come from Italy and now I'm working at the Helmholtz Institute Ulm as a PhD student. I'm working in the Poly Storage project, which deals with the development of new polymeric materials as electrolytes and active materials for lithium-ion batteries. I'm dealing with the topic of hybrid organic batteries, which are batteries made of a lithium metal anode, a polymeric electrolyte, and a polymeric active material as cathode. And in this video, I would like to show you how I work daily in the laboratories and how I carry on some of my research activities.
When I want to test the electrochemical performances of a cathode material or of a polymer electrolyte, I usually assemble a pouch cell. The cells has to be assembled in a dry environment to avoid the presence of water in the battery, since it's very detrimental for the performances. That's why I work in a dry room, where the amount of water in the air is just some parts per million, and I wear this FFP3 very heavy mask to avoid breathing on the cells. You have to be very careful if you work many hours here and make some breaks outside, because after a while you become dry too. Here I'm assembling a cell with a polymer electrolyte. I start with the empty cell with just the current collectors, and first I put the lithium metal. The lithium metal is the anode of our battery that is attached to the aluminum current collector, and then I put the polymer electrolyte, which is this transparent membrane that is placed on top of the lithium metal. The last step is to place the cathode. The cathode material, this black disc that goes on top of both the lithium metal and the polymer electrolyte. The final step is just to seal the cell, check that it's working, checking the voltage of the cell, and then if everything is alright, you can go and start your test with this cell. When the cell is ready, I connect it to our macro cycling system in the basement, and here I can set up the parameters of the experiment I want to perform. The test here can last to some days, to several weeks, to many months actually, according to what you want to see from your material. For instance, a rate performance test is pretty quick and allows you to see how the capacity of your material changes when the applied current is increased or decreased. Instead, a long test with many cycles can be used to see how stable is the performance of your battery with many cycles of charge and discharge, and this thing can take many months to complete. When the test ends, I usually perform some analysis on the cycled batteries to understand how the materials change during the cycling. This is another kind of cells with respect to the one I showed before in the dry room. Here the cathode is made of a redox active polymer. First, I have to open the cell in a protected environment like this glove box. Inside the glove box there is only argon, an inert gas that does not react with the materials of the batteries that are now exposed to the atmosphere. The lithium metal and the cathode are first washed in a solvent to remove traces of electrolyte, and then they are transported out of the glove box to dry them more and to prepare the samples for other tests. Among the techniques I can use in this phase, the scanning electron microscopy is for sure one of the most interesting to see. I use the electronic microscope to look at the surface of the materials with a magnification of the image that gets to the order of nanometers. I really like it since you are able to look directly to the face of the materials that you use. For instance, here I see the formation of a solid interface on the surface of my cathode material, which is probably due to the interaction between the electrolyte and the cathode itself. Using the energy dispersive X-ray spectroscopy as shown here, I can quickly check which are the elements that form this interface.
So this is just one of the standard processes that I follow during my research activities. There will be like many things that I would like to show you, but like just even like the amount of reading, studying and training that you have to do before and after each of the steps I showed you. So I hope that this was nice to see for you, and for all the interested people, I invite you to follow the Helmholtz Institute Ulm and the Poly Storage project in the website and in the social pages. Ciao!